Hello everybody, I'm Emre Koçyiğit. I'm a doctoral researcher in the University of Luxembourg. In this video series, I will try to explain the feature engineering techniques. While teaching machine learning, I observed that so many students were confused about the feature extraction, feature selection, dimensionality reduction, feature transformation, and this type of terms. Therefore, I decided to prepare this notebook which shows the big picture of the feature engineering techniques and clearly explained the differences between the feature extraction, feature selection, and this type of terms. And I will explain the techniques and I will show some examples in the Jupyter Notebook. Okay, let's start. And first of all, before understanding feature engineering techniques, you should understand the machine learning pipeline. So this is a standard pipeline. First of all, you should understand the problem, of course. This is the most critical step. Then the next step is data acquisition. So you can collect a data, you can scrape data from websites, from social media applications, or maybe you can just write an SQL query. Then you can get your data, or maybe your data is already there. Okay, but then the next step is understanding the data. We will apply exploratory data analysis steps, data visualization, data analysis techniques at this step to understand the data, the relationships between the variables. This is very important. Then usually the next step is feature engineering. So just before the modeling and training, with feature engineering techniques, we can increase the quality of the data. And if you are familiar with the fundamentals of machine learning, so probably you heard the common rule, garbage in, garbage out. So to increase the quality of the data, we can apply different techniques. But of course, this is not one directional and sequential process. For example, after modeling and training, you can evaluate the model, then based on the evaluation, based on the results, you can go back to feature engineering or you can go to the data acquisition. So this is quite dynamic process. Even after deployment, maybe you will face a problem, then based on the problem, you can go to feature engineering and you can improve your features, you can increase the quality of the data, and you can have better models. Okay, I think that part is clear, so let's look at the feature engineering pipeline. Before understanding the techniques, I want to show this pipeline. So we have 4 common steps: feature understanding, feature structuring, optimizing, and evaluating. Sometimes you will have structured data, therefore you can skip that step, but let's think that we don't have structured data. As usual, in real life scenarios, you will mostly have unstructured data. So step by step, I will explain this pipeline, then we will go to details of feature engineering techniques. The first step is understanding. So as I said, we can have structured and unstructured data. So unstructured data, basically image files, text files, or some PDF, HTML. The unstructured data cannot be used to train the model. We need to convert this unstructured data into structured form. For example, tabular data. Remember the machine learning training data sets. We have rows and columns. So each column represents one feature and each row represents one sample. And I will give you a real example. Let's assume that we want to build a URL-based phishing detection model. So there are some websites, fake websites, they are not legitimate, not official, and the attackers design these websites to steal your money or to get some confidential data. And our target is building a machine learning model which can detect these phishing attacks by using URLs. So URL-based phishing detection model. Then, under the feature understanding, you can ask these type of questions. What does a URL look like? What are the elements of URLs? Of course, you should check the literature review. You should inspect the benchmarking studies, similar projects. What are the features? What can be the feature definitions? After some time, it will be a bit time consuming, but after you really understand the potential features, you can define some features. For example, this is the structure of URL. As you see, we have protocol, subdomain, main domain, so top level domain, directory, etc. So, and also you can see these are the possible characters which can be used in the URL. Based on your study, based on your research, and also considering similar studies, for example, you can say that the length of a URL can be a feature. So you can define a simple Python function and it can calculate the length of the URL. Then you can have a numerical value for that feature. Or you can create a categorical feature like top level type, and you can just extract the top level domain. It can be or, com, other types. So these will be categorical data. These are just simple examples. Then second step will be feature structuring. Again, as I said, if you have a structured data, you don't need to apply this step, but usually, like in this example, we will have unstructured data. For example, think that you will have a list of phishing and legitimate websites URLs, and maybe you have only two files, text files, and in the text file you have these URLs, okay? Different URLs for different websites. And the idea of structuring is converting this data into this structured data, tabular data. Then each line has a URL, each row will have the information about one URL, and for example, we have a feature like length of URL, then for each URL, we will have some values. Of course, you can have more features here, and if you know the label of each URL, you can also add label column, and then you can simply apply supervised learning. So at this step, we are applying feature extraction, which is an important feature engineering technique, and I will elaborate the feature extraction under the feature engineering technique section, okay? But simply, if you have raw data, you can apply feature extraction, then you can have some features. Then the next step is feature optimization. Actually, this part will be the most time consuming part because you will try to increase the quality of the data, and we know that with best data you can have best models, and we can apply 4 different feature engineering techniques under this step: feature improvement, feature extraction, feature construction, and the feature selection. As you see, they are not same, they are different techniques, and I will elaborate all of them for you. But the idea is you can apply different techniques to increase the quality of the data, your features, and that step is a part of feature optimization. After optimization features, now you have the features, you can build and train your model, and you can evaluate your features. So the last step is feature evaluation. Again, here the best practice is choose a simple algorithm because probably you will have different scenarios, different feature sets, different strategies. Then you can compare these feature sets with the same algorithm. You should not change the hyperparameters. And usually the best practice is choose simple and fast algorithm, then compare the results and go with one feature set. Then you can apply some module optimization techniques, hyperparameter optimizations to enhance the performance. Okay, that was a brief summary of feature engineering pipeline. Now, let's look at the feature engineering techniques. So we have 5 different feature engineering techniques, and these are feature improvement, feature construction, feature selection, feature extraction, and the feature learning. In this notebook, I will focus on the first 4 techniques: feature improvement, construction, selection, and extraction. And feature learning is a part of deep learning models like CNN, convolutional neural network. The idea is deep learning model can learn features automatically, and it will be very helpful for us in specific problems like image classification or face recognition, etc. But in this notebook, our scope is the first 4 feature engineering techniques. Now I will explain feature improvement, our first technique, and I will explain other techniques in the following videos. With feature improvement, we are not changing the dimensions, we are not adding new features, but we are trying to improve our existing features. And one of the scenario is you can have missing values and you can impute these missing values as a part of feature improvement. I will show you simple data set. Here we have diabetes data set from scikit-learn, and I will use pandas and numpy. Let's import them. Okay, we can load our data set. Then we can create a data frame by using pandas data frame, and I'm using the diabetes data, and for the columns, diabetes feature names. So as you see here now, we have a structured data, we have a tabular data, and these columns are the features for us. Let's look at the information of this data set with pandas info method. You can see we have 442 entries. They are all floating, they are all numerical values, and we don't have any missing value. we don't have any null value. So I will add some missing values. I will add a new column and we will have some missing values in this new column. Then I will show how can you input these missing values. So let's create a copy. And this is the first 10 rows. Okay, first I'm using head. I hope you are familiar with the basic methods of pandas and numpy, because I will not explain the details of the methods. But as you see here, we have some numerical values. Then I'm adding a new column. Okay, name of the column is new feature, and just I'm adding random values. And with this part, with this block, I will convert 20% of this column into non-values based on the missing value ratio. So multiply missing value ratio with the length of df2, then convert into integer, then randomly create some index values. So using these missing index values, I will convert the values of the new feature into none. So let's run it, and now let's check df2 info. We have 442 entries, and here we have a new feature, new column, and as you see here, this is not 442, so we have some missing values. Of course, it will be hard to read and check missing values by info, especially when you have a lot of features. Then simply, and the best way, you can use isNull method. And with any, we can check that, as you see here, for the first features, we don't have any missing value. But if you see true, that means for the new feature column, you have some missing values. Okay, we detected missing values as a part of feature improvement. So how can we impute these missing values? There are different strategies, and according to different scenarios, you can apply different strategies. I will show you one simple example, but you should know that there are different scenarios, different strategies. And in this scenario, we have only 20% missing values, so we can impute that one. But if you have 80%, 70% missing values, you can also consider to remove that column, because maybe you have a lot of missing values and imputing will not be very beneficial. Even it can be misleading. So here, from scikit-learn input, I'm using KNN imputer. The idea is simple. If you know the KNN, here we are using nearest neighbor algorithm, and for the missing values, it will check the closest sample, closest and most similar samples, and I set it to, that means based on two closest nearest sample, it will fill the missing values. So first of all, instantiate imputer, then we will fit and transform this imputer our data. Of course, be careful here, while you are fitting that imputer or other preprocessing objects, you should use training data. Okay, for this example, I didn't zip it into train and test, but you should always fit your preprocessor objects with trained data. For testing data, you should only use transform method. You shouldn't use fit method. Okay, I will show for the standardization part, but be careful about that, otherwise it can be data leakage. Now let's look at them. Okay, we used KNN, and as you see here, for the new feature, we don't have any missing value. Again, there can be different scenarios. Maybe you have some rows. Those rows have a lot of missing values, then you can remove those rows. Or for some other problems, you can also calculate the mean and median, then you can fill the missing values with median and mean. And here I have a note from the book of Özdemir, Feature Engineering Bootcamp. If you are dealing with data at nominal or ordinal level, then we can fill missing values by using the most common value, the mode. But if the feature lives in the interval or ratio level, then you can use, for example, Pythagorean means or the median. So as you see here, the data type is crucial while deciding the strategy. This is a simple example of feature improvement. If you have missing values, and if you are imputing, if you are removing, if you are dealing with missing values, that means you are improving your features. Okay, and next step can be standardization under the feature improvement. Again, the critical point, we are not changing the dimensions, we are not adding new features, but for the existing features, we are applying some techniques to improve the features. And first of all, let's look at some statistical information here. You can see they are scaled, okay? So I need a data set which is not scaled, and I will use breast cancer data set again from scikit-learn. So let's import it and let's load it. Okay, so again, from this data set, I can use the data and the feature names, and I can create a data frame. And the first 5 rows, here you can see we have some features, and they are not, obviously they are not scaled, but we can check the statistical information. df data frame describe method will give us statistical information, transpose of this data frame. Here you can see we have minimum value, maximum value, and they are not same. So these features are not scaled, they are not standardized. So how can we do that? Actually, we have different options, but again, be careful. This is a part of pre-processing. So we are improving features, but we should only use training data. So I will show you one example. First of all, let's create X and Y. So our data frame, as you see here, we have only features. We don't have the target column in our data frame. So I'm using data frame to create X. But if you have the target label here, be careful. X should not have the target label column. And the Y, here I'm using cancer target attribute, okay? And the column name will be label. So by using this X and Y, I can create a training and test set. Okay, so I'm using scikit-learn model selection train test split. It is very useful method. You can give your X and Y, then you can specify test size. So 0.25 means 25% of my data will be test data and 75% will be training data. And random state is just to control the randomness. And in scikit-learn, under the pre-processing, we have different scalars: standard scalar, min-max scalar, robust scalar. The standard scalar is z-score normalizing. Mean scalar is the maximum value will be 1, minimum value will be 0 after min-max scalar. And robust scalar, especially when you have some outliers, this is more robust against outliers. We have also other scalars. These are the most common ones. And for example, for the standard scalar, first of all, you should instantiate a standard scalar. Then, to fit this scalar, again, we are using only training data. Be careful here. And for the test data, use transform method. Okay, we don't want to have data leakage. And if you check the minimum and maximum values for one specific row, after the standard scalar, these are the new values. But if you have min-max scalar, okay, again the same steps, you can see minimum value is 0, the maximum nearly 1. So we have different options. This scaling, these normalizing steps are part of feature improvement technique, okay? And the next step, again, we are not changing the features, and we are not changing the meaning of the features, or we are not adding new dimensions, but still we are trying to improve the features. And removing outliers is also another important step and technique under the feature improvement. We know that especially some algorithms are quite vulnerable against outliers, and they can mislead our model. Therefore, we should detect outliers, and we should clean our data. How can we detect? There are different techniques. You can use statistical information, for example, data frame describe, and you can compare mean value and standard deviation to see potential outliers. Or the best way is using visualization techniques, box plot, for example, then you can spot some potential outliers. Or you can apply statistical methods, z-score, IQR, etc. But the idea is this one technique or one method is not enough to really decide about outliers. Usually they will give you potential outliers and you should inspect. We should inspect and then decide. And how can we deal with these outliers? Again, we can use imputation techniques. Maybe we can remove them. Maybe based on our domain knowledge, we can customize, we can remove them. Capping, windowing, there are different techniques. Let's look at one example. I will use matplotlib pyplot. So first of all, check statistical information. Here you can basically compare mean and standard deviation. Okay, and for example, here you can see for the area error feature, standard deviation value is even bigger than mean value. So this is an important outlier symptom for us. So we should inspect this feature. Okay, and let's plot, and let's use box plot for this feature, area error. You can see we have the median value here, the maximum, minimum, the edge values are here, but these circles are representing outliers, especially these two circles more than 500. They are really outliers for us. But if you look at other feature, mean radius, you can see the distribution is a bit normal, median and maximum, minimum values, and we have 27, 25. But in this example, we have here 100, okay, and we have a lot of data points more than 100, especially we have 500. So let's look at area error, and we can simply define some conditions inside this data frame. You can say that check only the samples which are bigger than 500 for this feature, and based on your domain knowledge you can inspect it. If you see any anomaly, any problem, maybe you can remove, you can fix it. So that is another story, but in this notebook, in this video, I want to highlight that detecting and dealing with outliers is an also part of feature improvement. Okay, so that's all for this video. Now the next step, next feature engineering techniques is feature construction. Here we will add new features. We will sometimes use existing features to add new features, or we will convert existing features into new features. So basically we are constructing the feature sets, so we can change the dimensions, we can change the features. So what is the difference between feature improvement and feature construction? So when you apply feature construction, the interpretability of the feature will change drastically. For example, maybe you have only height feature in the data set. You can use a new feature. For example, you can add weight. So this is a part of feature construction. Or maybe you have height and weight, and by using these two features, you are creating a new feature as BMI, body mass index. So that is also feature construction. So I will elaborate and I will show Python examples for the feature construction in the next video. So thank you for watching and see you in the next video.